I thought I'd start a new series. I've been seeing a lot of questions about circuits by beginners on Reddit. So I'm going to review the circuits and maybe make improvements to them if I can, and show you some better techniques. Obviously, they're not going to be completely error-free because there's only limited time that I can put into this kind of stuff. But I'm hoping it can be a collaborative thing where, everybody from my audience kind of joins in to give hints and tips on how the circuits can be improved. I'm going to try to keep it so that we are not diving too deep into the kind of circuit itself, but rather the point will be how to lay out a good schematic, how to lay out a good PCB, rather than where to connect tracks, basically, because all circuits are different and that would just take too much effort if I have to dive into each and every microcontroller and IC that people use. So let's get started. Now, if you look on the screen now, you can see I've basically already selected a question. This is from user delicious.0355. Reading usernames is probably a bad idea for Reddit, to be honest. But yeah, it's delicious.3055. So the circuit they have is a ATTiny85 tiny something. I'm not too sure. But yeah, you can just about see the part number here, and in their comments you have ATTiny85 dev board. They have a AMS 11750 regulator, which I believe is a 5-volt regulator, so I assume there is a 12-volt or something power supply coming in to this board. And you can see the circuit, it's not great, but it's a start. Someone's made an effort. So let's try to kind of show best practices when designing a circuit like this and how potentially they can improve it. So you can see on, there's been a lot of feedback already on this. I think this feedback was from myself with my random Reddit account that I have. I also have a engineering experience Reddit. So if you want to reach out to me on there, you can do so. Okay, what I'm going to do is basically recreate the circuit because obviously I don't have the person's design files. Hopefully, going forward, people reach out to me and send me design files so we can improve them straight from there, really. So that would be better. If you have a fun name for this series, reach out. Maybe I'll use your name. Right now, it's going to be Reddit reviews. A bit boring. Let me know if you like this idea as well. I think it's going to be quite fun. I'm going to enjoy it. Obviously, the Art of Electronics exercises and solutions is still ongoing and will be. I don't plan to finish on that soon because, it's a massive book. We're only on 2.18 so far. I think 2.18 part B should be released. So check that out as well. So keep this circuit in mind and I will bring it onto the screen when I can. So what I'm going to do first is open KiCad. I'm going to make a new project. So file, new project. I'm going to create a new project called ATTiny85 because that's kind of the main board in this. I'm not sure what they're trying to do with the board itself. They've just got a connection that's going out from all the pins. So let's start that. We don't also have a PCB design in this case. So we're starting off very simple. I'm going to put that to the side over here. I'm going to bring out my schematic editor and put it to this side. The first thing I want to do is basically set up my page so that I have a A4, which is fine, I think, in this case. When I do revision draft 1, I'm basically going to fill out all of this information. So you can see now I've got a schematic. I've filled out some details over here. And I'm going to make this a little bit larger. You can see on the schematic itself, they start off with J1, which seems to be the main kind of supply. So I'm going to go connection, 0102 pins. And I'm going to put that somewhere here. And looks like a power supply. So I'm going to call VS in, basically the reference for this, and leave that as J1 because that's what they have. Now J1 pin 1 is an input. So I'm basically going to take that out. So what I've done there is hover over this pad over here or this pin connection, click down and just drag that out. I'm going to put down a net label. And I'm going to call that VS plus and add that to the net label. Next, I'm going to add a ground symbol. Again, doing the same thing again. Then I'm going to go into add a power. So pressing the P key and I'm going to search for ground. and add a ground symbol to the schematic. I don't like seeing this ground everywhere, so I'm just going to get rid of that. But that's personal preference really, what you want to do. Now you can make this shorter if you want to. You can see I've kind of messed up my net label. So we got a VS Plus. You can also use these net labels. They look a little bit better, but they're global. So it's just something to keep in mind. But you can do this and they look a little bit better in my opinion. So we have a VS and then they have a regulator, which is a AMS11750. I think before we dive too deep into the circuit itself or improving the circuit, let's just talk about what the circuit's doing. So we have a 5-volt regulator, we have a microcontroller, a reset circuit down here, and I think this is a power indicator. But you can see the circuit is quite messy in that, all the ground connections are connected together. I think that could be done a little bit better. The capacitors are sideways, they're all connected, butted against the pin connections of the symbol itself. Same thing over here. You can see this connector is butted against this pin, or maybe there are some tracks in there. Not a big fan of the color scheme, but that's fine. And then you have some connections over here, which I think generally this is kind of the good part. And then you have an unconnected net over here that should really be deleted as well. So you get rid of this tie dot. So I'm just going to tidy it up. I don't think there's particularly anything wrong except for one thing, which I'll talk about in a bit. So next we have a regulator, which is AMS117-5. Now this regulator is linear. It needs a input capacitor and an output capacitor, which you can see they've added. Not sure what values they've added, but what you should really do is go into the datasheet for the part so that you can add the right value capacitance that you need for the part. So in this case, I'm just going to have a quick look at the datasheet for this part, make sure we get some right value capacitance values, because you should really have them over here as well. I think that says C10, maybe they mean 10 microfarads. I'm not too sure. I'm going to delete this, add a net label in there, VS Plus. If you know what that voltage is, let's say it's 12 volts, then maybe you can do 12 volts in there as well. Next, I'm going to basically connect up the output capacitor. Now you can see they have it so that it is connected to pin 2 of J1 and pin 1. So this capacitor over here. So pin 2 is basically the ground. So that's this connection over here. So that's what I'm going to do is connect up this ground to this junction over here. So you can see that's a little bit neater. Now, to improve this circuit, what you can do if you want to, some people prefer it, some people don't, it's up to you. I do like it, is basically put down a box around this. You can also talk about, and basically just add in a description for what this block of circuit is doing. So this circuit is a 5-volt regulator that can provide up to 100 milliamps. You can also add in more information. For example, if you did any calculations for some of the components or things like that, would be useful. Basically, when you come back to this circuit in a year's time, you know what's going on. Or if someone else comes along and looks at this schematic, then they know what's going on. Or if a PCB designer looks at the circuit, they can say, oh, okay, there's going to be 100 milliamps coming in this direction. So I need to make this track sufficiently thick so that it does not overheat. So you can see I've got the capacitor C2. I'm going to try to basically keep it the same labels so that it's, can be followed along. So that's C3. I think these are 10 microfarad capacitors, but I'm not 100% sure. So I'm just going to have a quick look. AMS117-5. See if I can find a datasheet for it. So I found the part, AMS1117. I'm not sure what the manufacturer is going to be, but it's a generic part, and you can see it's a 10 microfarad capacitor on the input and the output. I'm not going to go into any more detail than that because too long. So I'm just going to change them to 10 microfarads. So a point of feedback on this circuit is, you should put the values of the capacitance of the capacitors or any other component basically. So I think what they've done is just done C10, which that should be 10 micro. As you can see, they've done similar for this 10K resistor as well, where they've done R10K. I think that should be just 10K. Now, if you look at this from the output, which is basically pin 2, over here, you have a LED that's connected to ground, which is very interesting. And that is basically a power indicator. The connection right now looks like this. So you've got your 5 volts connected to this LED going back to ground. Now you can see what's going to happen. This LED is going to blow up as soon as you power up the circuit, most likely, because this LED is probably rated for 2 volts, 3 volts, something like that. So what you need to do is have a resistor that's in series with something like this, so that you can basically limit the current that's flowing through the LED. Now that will depend on the brightness that you want from the LED, how much current the LED is rated for, the forward voltage drop of the LED. So let's say this LED is rated for 2 volts, so it has 2 volts drop in the forward direction, and you want to pass 1 milliamp through it. If you're passing 1 milliamp through this LED, that means that there's going to be 1 milliamp flowing through the resistor as well. This is a 5 volt regulator. I'm just going to add a net label as well. So 5 volts. Another type of net label you can add is basically a power symbol, which I'm sure we had somewhere. It's basically this kind of symbol over here. So I think that might be a little bit better, which we can do for the VS as well. I think a feature introduced with KiCad 8 is you can change these labels. So I'm just going to call that VS. And we got 5 volts over here. So as I was saying, you have 2 volts over here. That means that you're going to have 3 volts across this resistor. If you have 3 volts across this resistor and you want to pass 1 milliamp through it, you can use Ohm's law, which is basically V equals IR, to calculate the resistance that you need. So R is going to be equal to V divided by I. So in this case, that's going to be 3 volts divided by 0.001 because that's 1 milliamp. And then that gives you I think a resistance of 3K. But you should do your own calculation for what you need to do. So I'm going to change this value to 3K. Now you can see we've basically corrected this error on the circuit, and it looks a lot neater than it did in the past. I'm going to add a box around this as well, just for the sake of consistency. I'm going to take this symbol and label this as power input. Next, they have a ATTiny85, and you can see -20p over here, which I think I found a symbol, Tiny85 -20p, which is basically this symbol over here. What I'm going to do is just add this symbol over here, put a box around that as well, and label that as microcontroller. Now for the microcontroller, you have a ground pin, which is basically the same connection. We're going to use this ground pin over here, so that's connected to ground. You have VCC, which is the 5 volts. So I'm going to use this 5 volts over here. Now, one of the things that this circuit doesn't have at the moment, as you can see, is a kind of a decoupling capacitor on this microcontroller. It's probably a good idea to have one. What I'm going to do is go over here and add in a couple of decoupling capacitors for this circuit. And they should be placed very close to the microcontroller on the PCB. So I'm just going to add a 100 nano and a 1 microfarad decoupling capacitor. And the capacitors are generally connected to ground. So a tiny improvement, I guess a big improvement, because that could cause the circuit to not work in this case. And yeah, that should basically keep the power stable for the microcontroller when it's trying to, do its fast switching. And if you want to make it neater, you can move this around as well. Some things you can do is add notes for the PCB designer. Keep close to U2. So these notes are useful when when you're designing the PCB itself. Just going to move that over here. But next, we have a connection which is J2 and it's 5 pins. So just bring in a connector on 5-pin connector over here. Just rotate that around by pressing R. And they've got pin 1 on top, so I'm just going to mirror that as well. So all of these pins are connected to the connector, so nice and easy. But I think one of the things that you can do for a more complex board is going to be more important, is put net labels on these as well. So basically going into over here or pressing the L button on the keyboard, we have PB0, we have PB1, PB2, PB3, and PB4. And then I'm going to add a suitable reference for the kind of the value of the connector. So IO expansion, I think, if I can spell. You can call it what you like, really, but it needs to mean something to people who are going to read the schematic. Next, you have a kind of a reset circuit over here, which goes to 5 volts, you can see. So VCC over here, we got 10K resistor. So going into my components, we have R, we have a 10K resistor, then we have a capacitor at the bottom. The value for that is not given, so I assume that's a 100 nanofarad capacitor. And obviously that goes to the middle there, as you can see, between the capacitor and the resistor. This goes to VCC, the 5 volts. You can see it's getting a little bit crowded over there. So what I'm going to do, I can move that out. Got plenty of room on the schematic, so there's no need to make the schematic crowded at all. I'm going to add a net label. So I'm going to call that reset. If it's active low, you can basically do n reset, lowercase n as well, and then add a ground symbol over here. Finally, we also have a switch, which is fine. So just go into here, look for a switch, rotate that around just because that's how the direction they've got it. It's nothing wrong with it. And you basically connect up a power symbol to it. You can see that's connected to ground over here. So now you have a 10K resistor. I'm going to assume that's okay. I'm going to assume this is connected all properly. I missed the ground. And you've got the switch. You notice that I didn't connect this up down here because generally not a good idea. You want to keep your connections separated like this so that it's more obvious that, this is connected to this node. This is connected to this node as well with the tie dot, with the tie dots. What you can do with the switch is you can add the part number for the switch if you want as well. So, you can add in a part number there, or if you want to add in the type of switch it is, like a tactile switch or something, then that's something you can do. So you can see we've improved the circuit. We've made it a lot easier to read in that, you can actually see what's going on now because the ground labels or the ground tracks are not just, going everywhere around the circuit because they don't need to. We can just connect them up with this ground symbol. We have our IO expansion labeled. We have our power supply labeled. We've corrected the resistor as well, or added in a resistor so that this LED doesn't blow up. Yeah, generally improvement from what we saw. I've added these boxes around the subsections, basically just to explain or add a bit more detail about what's actually going on. I won't go into any more detail over here because obviously this is a very basic circuit, but in future when these circuits are a little bit more complicated, maybe we can talk about, class directives, adding labels to all the different wires where we can specify track thickness, minimum track thickness, and things like that for the circuit itself. I think this should be fine. If you have anything to add for like feedback for this person, let me know in the comment section below. Obviously you can go into Reddit. This Reddit is ArchiCAD. I do have my own Reddit, engineering experience, if you want to join there and, post your own schematics. So you can do that. And this series is going to be very beginner friendly. So, if you're more advanced, I think you can still watch just so that you can share your knowledge with the people and, make sure everyone learns electronics. Thank you for watching today. That's all I have to share. So this is the kind of final circuit that we got from this user who started off with a circuit that looked like this. Obviously, it's very messy and had a few mistakes in there as well. We've corrected all the mistakes and we ended up with this circuit over here. And obviously, it's a lot easier to read, I think. And, we've corrected all the mistakes. So hopefully, the development board that they're, I think, trying to build over here should work. I'll post a link of this video on the subreddit if it gets attention. You know, I'd rather get views than not get views, so that's what it is. Thank you for watching today. Don't forget to share this video. Don't forget to like. Check out some links in the description if you want to learn electronics yourself. I've linked some dev boards and things like that in the comment section, in the description section. So check them out and I might get a little bit of royalty. Thank you for watching today. See you next time.